Welcome to the show. As part of the German Embassy and Ghana Broadcasting Corporation's collaboration on the Climate Talks project, we've traveled all the way to the Ashanti region. This is Jankoba. We've come to the first waste-to-energy hybrid power plant in Ghana. And on my side here is the plant manager here, Mr. Onana Ashi. I'm happy to be here. And tell us a little bit about this project. How did it start? Who are the collaborators?
Yes, the collaborators is government of Germany through University of Rostock, and also Ghana government through CSI, many university in Ghana, like KS University, and also the main partner also here is Waskar. Yes, that is the main partner involved in this project.
And what is the idea behind this hybrid power? What is a hybrid power plant in the first place?
Hybrid power plant is, the idea is to combine many types of energy sources to produce the energy. So the source, the particularity here is the sources of energy are all renewable, not energy from fuel. Yes. So we are using waste to convert to energy, and we add another renewable energy sources, that is solar. Yes, that is the mix of all that is calling hybrid.
Okay. Where does the waste come from?
Yes, the waste come from municipality mainly. Yes, the municipality supply us the waste. Yes,
And then by the time the process is over, you've gone from waste
to
energy.
Yes,
But let's start with the lab, because I understand some great things happen in the lab.
yes,
Can we go there?
yes.
Okay. What happens in the lab?
In the lab, it is where we are doing all the analysis and experimentation for different process, mainly for the gas production, because
Okay.
we are convert organic material into biogas.
Okay.
After that, we purify the biogas and then use the biogas to produce electricity.
Okay.
The electricity at this time is used is for internal use inside our plant.
Right. So this is your lab.
Yes, this is our lab.
Okay.
Yes, welcome. And I want to introduce you Mr. Alan, who is the technician lab, the boss of the lab.
Okay.
Yes.
All right. Okay, Alan, happy to meet you.
Same here, Sakafui.
What's your role here? What do you do in this lab?
Okay, so like I already mentioned, this is the biogas lab. Here, we consider a very critical part of the entire process. What we do here is we do feedstock quality monitoring in the lab. We also do analysis of the feedstock once we have placed it into the reactor, which we call the digester influent.
What is this feedstock?
Okay, so in this facility, we utilize municipal solid waste for our processes. So in using the municipal solid waste, we intend to produce biogas from this municipal solid waste, the organic fraction specifically. Now, when the municipal solid waste comes in, it is heterogeneous in nature, in that it comprises of organic and inorganic parts.
Okay.
So the feedstock I'm referring to is the organic fraction, because that is the part that goes into the reactor.
When you say municipal solid waste, is that the poo of the people? People's poo?
No.
What is it?
No. So like I said, it is heterogeneous. So it comprises of, you can see a lot of things in
Like
it. You
what?
can see plastics, you
Okay.
can see organic materials, you could see metals, glass, you could see textile, paper waste. All of these are in the mix of the municipal solid waste.
Okay. And then, so tell me what happens when it comes.
Okay, so in the lab, once the municipal solid waste comes in, it normally comes in skip trucks. So once it comes in, it goes to the first point of contact, which is our bunker, where the waste is offloaded. So once the waste is offloaded, it is the responsibility of the lab to sample and then get to do analysis on the organic fraction or the organic composition of the waste.
Okay.
This gives us a prior knowledge about the nature or the characteristic of the waste that came in.
Do you have any waste here that we can have a look at?
Yes,
That's
they are in our
elements.
refrigerators.
Yeah.
So if you could.
We want to see.
Okay,
Yeah, we're
that's fine.
curious.
Okay.
Show us the waste.
Okay. So this is one of our refrigerators we have, a freezer. So you can see a stockpile of waste.
Okay, so
here.
describe what I see. What
So
is this?
this is a typical example of organic fraction of municipal solid waste. So in this mix, this is actually blended. So in this mix, you have a combination of kenke, husk, you have fruit waste, vegetable waste, all in this mix. And these are the organic fractions we recover from the heterogeneous municipal solid waste that comes in.
What is this?
This is cassava peel, which has been shredded.
Okay.
You know, for the anaerobic digestion process, particle size reduction is very important.
Just make it smaller.
Yes, exactly. So this has it has been taken through mechanical pretreatment, which we use this particular system. So once the cassava peel came in, we placed it into this system and then shredded it to a specific size.
Right.
And that is what we have in there.
What's this?
This is the cassava pulp. So you know the cassava comes with the pulp and then the peel.
Okay.
So this is the peel that has been, shredded, and then this is the pulp.
So where did all this waste come from? It was just
These were parts of the municipal solid waste that came.
okay.
Yes. And then because we wanted to analyze the biogas potential of the organic fraction, we sorted out specifics. So the cassava peel and the pulp are specific organic fractions that have been taken from the bulk that came in.
Okay.
This, on the other hand, isn't specific. It is specific in the fact that it is organic waste, but then as to it being specific, as in, are you just taking vegetable waste? In the vegetable waste, are you taking only cabbage? So
you're breaking things down.
So that is the breakdown. So these are specifics that have been taken from the municipal solid waste.
Okay.
And this is a mix of organic fraction of the municipal solid waste.
All right. Do you guys deal with fecal matter?
No, we don't.
Don't.
Yes.
So it's just like leftover food and
Exactly.
and all different kinds of things.
Yes.
Okay. So what are these? What are the contents of all these bottles here?
So the ones here, this is the cassava, the pulp. The pulp I showed you, the freezer.
Yeah.
So this is the pulp. And then before you feed the pulp, there has to be, like I said, the system is biochemical. So there's the biological part and then there's the chemical part. Microorganisms, bacteria specifically, play a very crucial role in this process. So before you introduce the feedstock you've identified into the system, you would have to make sure that you introduce what we call the inoculum. Inoculum is sort of the bacterial consortium. And the idea is that once the inoculum is present, and the inoculum comprises of bacteria, like I said, so the intention is to starve the bacteria, right? And then the feedstock, and I think now the term feedstock makes more sense.
Yeah, it does.
It is feed for this bacterial consortium. So once you introduce the feedstock into it, they break down the molecules, macromolecules in the feedstock, and then one of the end products is the gas that we see.
Ah, okay. Anything else of interest to us as part of your waste to energy
Yes,
process?
I think we can do 3 more.
Yes.
Yes, which are crucial. So when we were talking about the hot air oven, I made mention of volatile fatty acids.
Yes.
And I said we don't do that there.
Okay,
So
you
this
do it
is
here.
where we do the volatile fatty acids analysis.
Okay.
And this analysis is so important to our entire business here. So volatile fatty acids, these acids evolve as the anaerobic digestion process ensues. Right? So it is very important to keep a close eye on the values you get from this. So it's actually a pair. It's volatile fatty acids and total inorganic carbonates. When the digestion process is ongoing, you want to ensure that your volatile fatty acids, which is VFA, is at most 0.3. There's a ratio. So the ratio of VFA to TIC is at most 0.3. Once the VFA goes high, you could have system failure down there. The TIC serves the purpose of buffering the acidity in the reactor. So naturally, as the VFAs are increasing, the TICs, or the carbonates, are also supposed to increase to sort of buffer the system. and then we use this auto titrator to serve that purpose. So this is one of the mostly used equipment in the lab.
All right.
We won't talk about this that
Okay.
much. So
All
we'll
right.
go to our gas
Analyzer.
analyzer, yes.
So is this the last phase?
This is the last but one.
Last one phase. Okay.
Yes, yes. So our gas analyzer, like I said, we do a lot of biogas analysis in the lab. Now, once you have the volumes from the feedstock that you've analyzed, you want to do quality analysis of the gas, and then this system serves that purpose. So typically, this system is the continuous system I mentioned earlier. And this is our gas bag. So once you use this system to produce the gas is strapped into this bag. And then what you want to do is that you want to analyze the quality of the gas. And then the gas analyzer serves that purpose. So you connect this bag to the analyzer, and then it sucks out the gas and then reads the composition. It has sensors for important components of biogas like methane, carbon dioxide, and hydrogen sulfide. Some level of oxygen as well. So the analyzer serves that purpose. Now, this is the last equipment you're going to talk about here. And this we consider the heart of the lab, because most of our biogas analysis or biomethane potential determination is done with this system. And we are fortunate to have 3 of them. They're all the same, they serve the same purpose. So once you go on field, the big tank you see with the white tarpaulin, that's a large-scale reactor. That's our large scale, and this is our lab scale.
Okay.
reactor.
So it's a mini version of this.
Yes, exactly.
Okay.
Exactly. So before we take any feedstock onto the large scale, we have to do lab scale analysis to ensure that the feedstock we are putting in there would give us the results we want.
Okay.
Yes. So that is why initially I said the lab is a very critical part of our processes, because everything starts in the lab. Okay. As the process is ongoing also, there's monitoring of biochemical processes also in the lab. Yes.
Before we leave, there's one question on my mind.
Okay.
I remember seeing the waste inside the fridge. Why did you keep waste in the fridge?
Okay, so it is organic, and then it may go bad.
Okay.
in layman terms. So keeping it in the fridge serves to preserve it till the time that we are ready to use it for our analysis.
Okay. Thank you very much, Alan.
Thank
From
you.
here, where do we go?
So we are going to the field,
Okay.
where we are going to see the waste receival point, which is our bunker. We are also going to see a sorting line,
Okay.
and then the product development sections as well.
So, Mr. Ashi, where are we now?
Yes, we are in the weighing, when we receive the material is weighed here.
Okay.
We record the weight from the security. Yes, after recording, we are going to put the weight under the bunker.
Okay. So a truck comes on this, right?
Yes, the truck come on this. It stay here for some time.
Okay.
The time for us to record the weight,
The weight? Okay.
and then you bring it in under the bunker.
Okay. So we're going to the bunker now.
Yes.
How much waste comes in here? I mean, monthly, in terms of weight?
Oh, the plant have the capacity of 50 ton.
50 tons.
Yes, 50 ton a week.
A week?
A week.
Okay.
Yes, municipal solid waste.
Uh-huh.
That means average 10 ton or more per day.
Per day.
Yes.
Working 5 days a week.
Yes, working
Okay.
5 days a week.
And at the end of the process, how much energy can this plant produce? In terms of
when we are looking for the energies, we have solar energies. We
Yes.
have one section from that is produced energy is produced from solar panel, and also the biogas. The biogas. We are using the organic part of the municipal solid waste to convert it in biogas and transform the biogas to electricity.
Okay.
So that is the place where we receive all the municipal solid
So
waste.
this is the waste.
This is the waste.
Let's look at the waste.
Yes.
So this is the waste of people in the area.
Yes, the waste of that coming from the market. You can see.
Fish, I see rubber bags.
Yes, yes. It is mix
I
of
see
plenty rubbers,
Packaging.
packaging,
Plastic.
yes, plastic, bottle.
Bottles.
Yes,
So it's just dumped here.
yes.
Boom. And then now, when it's dumped here, what's the next step?
The next step,
This looks like chaos.
yes, but it is a raw material for us. This
Okay.
we give the value to all those wastes.
So you're excited when you see this?
Yes.
You're excited with rubbish?
Exactly.
Okay.
Because we know that we make some sorting
Okay.
and use it in different small sections.
Okay, how do you sort this stuff? This is smelly work, dirty work.
Yes, of course, but we have our process line. We have, we can go over there.
Okay. So it's dumped here.
Yes, the waste is dumped here.
Uh-huh.
So at this time, we are preparing to feed our sorting line.
Okay.
This can be good if you can also see how it is
Oh
working.
yes, we want to see it.
Okay.
We want to see it. Put the line on for us if it's possible. So the waste has come.
Yes, and we take the waste to the.
What is the role of this caterpillar?
Yes, the wheel loader, it is to load the waste.
Okay.
You will see the roll at this in few minutes.
Okay.
We take all the waste
Uh-huh.
and put it inside in the sorting line. This is the way we are calling the sorting line.
Sorting line.
Yes.
Okay.
Where we are sorting all the waste and so on to get organic part, inorganic part, rubbers, and so on.
How did that waste come to look like this?
Oh, that is the mix of plastic. After sorting, we have three kind of product we are looking for. The bottle, the used bottle, you will see
Okay.
them right now.
All right.
And after this is the mix of
the mix.
different
Different
rubbers.
weights.
Yes,
Okay.
different rubbers. After we washing, we see the washing line.
Okay.
We crush the waste, we wash the waste, we dry it, and we bale. We have a baling machine.
Okay, so I think at this point I'll wear my mask.
Yes.
Okay. Okay. So, who is feeding this into the stuff into the machine?
This is the wheel loader.
Okay.
The starting process is
Where's the
here.
start processing? It's here.
Yes.
Okay, so I want to see that.
Yes.
Ah, okay. Okay, so he's gonna start the process for us to see.
Yes. This is the beginning of the process. So we take the waste with our wheel loader to come and load the sorting line. This is the beginning of the process.
So what's the technical name for this machine?
We are calling wheel loader.
It's a wheel loader. Okay,
Wheel
so it's a
loader,
wheel loader.
yes.
All right. Okay. So he's gonna dump it inside here.
Yes.
Okay.
Not inside, outside, because here is designed for. We was thinking that in the designing, this place is. We are thinking that the waste we put inside the rubber.
Ah.
But it is not the case. This is some sack and so on. So we prefer to direct to put it in the conveyor.
Okay. So he's gonna put it inside here.
Yes.
His coordination has to be very good.
Yes.
Yes. That's somebody's seat.
Yes.
Okay, so this is going.
Yes. This is going. She's there to remove all the sacks. Some sacks are closed.
Okay.
So she removes them to empty the sack
Ah,
in the conveyor.
I see.
So the waste are going to the trommel.
Uh-huh. To go around.
Yes,
to
to
get
go
sorted.
around to reduce the bigger size, go to the other size, and the smaller size follow this line.
Okay, so this is going up there. I wish we could go and see what's happening over there.
Yes.
So let's go. So it's going, it's turning round.
Yes.
Why does it turn round?
Because they want to remove the inorganic material.
Okay.
To separate inorganic material and organic material.
Okay. It's almost
So-
like a centrifuge kind of action.
Yes. Yes.
Okay.
So this is inorganic material, like rubbers, like carton, like PHC
So,
bottle. Have you
so all
seen?
the inorganic stuff is coming out.
Yes, inorganic material
Oh. And where's the organic stuff going?
is the organic stuff going fall down and
Going
go
that way?
on that way.
Okay, so this is the inorganic. Let's go see the organic stuff. So this is the plastic and all that stuff.
Yes.
Okay. There you go. Ghanaians use a lot of plastic.
Exactly.
Damn. So this is the organic stuff.
This is organic stuff. As you are seeing, it is small size. We
Yeah.
have also some of small plastic inside, some rubbers.
So
and
it will
some
be
bottles.
sorted again.
Yes, again, as you are seeing, this is the plastic, and this one is the bottles. So after here, the way we can see, it is mixed with a lot of sand.
Yes.
So organic material plus a lot of sand, that is this part. After saving, you take it for compost.
So this is sand.
Yes, sand mixed
with organic
organics.
stuff.
Yes, that is the challenges of when you are processing the municipal solid waste. Because here we don't have the sorting at the source. So here we have to do all the work.
Yeah, because in Europe they sort already before
Yes,
you even take it. It's there's
Exactly.
plastic, there's glass, there's
Exactly.
organic,
Yes.
different colored bins.
Different.
But here we put everything together.
Everything
All
together.
play all.
So this is our challenge every
Yes.
day. So in our process, we are taking all this part as it is mixed with the sand. We take it to the compost. So normally we plan to use it to supply to feed the digester.
Yes.
Yes, because digester is using organic material. Now we have a digester over. So we collect all the municipal solid waste, specifically the waste from market, organic waste from
Market waste, yes.
and also restaurant with small bins. At this time, they are already sorted.
Okay.
So that is the way they are going.
So what are they doing here? Let's see what they're doing.
So they are on the process to fill the digester.
So this is some of the waste that came out from there.
This
Oh,
waste,
this is a different kind of waste.
this is the mix of waste.
Mix.
This waste comes from restaurant,
Restaurant waste.
yes, restaurant waste, and also market waste. Organic part of waste coming from market. So we collect all those waste. We make with cow. We also have cow dung.
Cow dung.
Yes, from the farmer.
From the
around.
farm. Cow
Yes,
dung.
yes. We collect farmer cow dung and also organic waste. All those are shred, grind, mixed together, and pumped in the digester.
Okay, so this is going up. Let's see where this ends.
Yes. This is cow dung.
Cow dung?
Yes, cow dung.
Okay.
We feed the cow dung from here.
Uh-huh.
And the organic, as the particle are smaller mix, we have to reduce the size.
Ah,
That is why we start from here.
I see.
And we mix all the two.
So different things are happening. Market waste is here.
Yes.
Cow dung is here.
But at the end, market waste and cow dung will be mixed
Together. Because they are all organic.
Yes. Because to have a good quantity and quality of gas, you have to mix material. Only one type of material is not recommended to get.
So do you have a kind of a percentage that you must respect?
Of course, that is the role of the lab.
Ah.
When we get the result from the lab.
When we went first.
Yes. When you went first, yes, the lab give us the ratio, the feeding ratio. Say, okay, if you have 1 kg of cow dung plus 0.5 kg of organic
waste.
the market waste,
Uh-huh.
yes, you can get this quantity of gas and this quality of. So
I
we
get you.
represent we take the result of lab and
And come and
take
feed
it
my people here.
Yes.
Okay. What happens to the plastic waste that you take out?
Yes, let us go
Okay.
to see the plastic waste, the use of plastic waste.
Wow,
At
this
this
is
time,
a really a lot of work, you know?
yes, yes,
How early do you start?
8 p.m.,
And then 8 a.m. and then you close what time?
5.
5. Okay. Monday to
Yes.
Friday.
Yeah, Monday to Friday, yes.
Saturday?
No, Saturday, no.
Okay.
Saturday is sometime we are coming to monitor the biogas production.
Okay.
Because the biogas is produced every day,
Uh-huh.
24 hour over 24, 7 over 7.
So this is the plastic that has been sorted.
Yes, you see it is plastic that called pure
Water.
Yes,
Not
pure
to-
water plastic.
Okay.
And it is PA plastic that is used to produce pellet.
Yes.
We produce pellet from this type of plastic, not the mix. You see, this type is different
From that type.
that type. Yes,
Ah.
this is a mix of
Uh-huh.
plastic.
What do you do with this one?
With this one, we take this to crush first.
You crush it.
Yes, we crush it. After we wash it, and then we bale it. We have a baling.
Then you bale it.
Yes, to get the bale we have seen here.
Okay. So you sell it?
Yes.
Okay.
Yes, people
Yeah.
are use it to the boiler.
Yes.
Yes.
So nothing is wasted here.
No.
You don't waste.
No.
Okay.
So
So from here, where are we going?
from here, let me show you the machine
Yes.
that is used for the pure water plastic.
Yes.
I follow the same process.
Yes.
This is extrusion machine.
Extrusion.
Yes, to produce the pellet.
Okay.
To produce the pellet.
Uh-huh.
So this machine needs only one type of plastic. We cannot use a mix of plastic. So
Okay.
that is why we are only separate and use only the pure water plastic
I get
to
you.
produce pellet
I get
from
you.
this machine.
I get you. So we've seen the waste and how it's sorted and how it's transported. How does it get to the energies? Okay, we have some cans here too.
Yes, we have some cans. This is for direct sell. We don't have the process right now to process the line to process this one. Same thing to the bottle. The
So who
PNT.
buys this?
Oh, there is some company in Kumasi.
Uh-huh.
Yes, buy this. Buy this.
I see. Interesting. So now the energy side. Let's look at the energy side.
Okay,
We've seen the waste.
Yes.
Now we need to see the energy.
Yes.
Yes. What are these white tanks I see here?
Yes, this is pyrolysis section.
Uh-huh.
Pyrolysis section. That means some of our waste,
Uh-huh.
the granule,
Yes.
will be used here to produce biofuel.
Okay.
This is the storage tank for biofuel.
These are storage tanks, so there's biofuel inside.
Yes, not yet. Yes,
Not yet.
because the work is in progress.
Okay, it's in progress.
Yes.
So after all this stuff have been sorted, the manure, the market waste, the mixed waste, where's the next level, next step?
Next step is to see how we convert biogas to electricity.
Thank you. Let's see it. How much of electricity can you produce here?
Okay, from the solar, the output of solar is 100 kilowatts.
Okay.
The output of the biogas, the gas engine, is 100 kilowatts.
Okay.
We plan also to buy another pyrolysis engine
Uh-huh.
that will also be 100 kilowatts.
Who uses this electricity that you create?
We are using inside.
For yourself?
Yes, for ourselves, internal use. Normally, the idea is to connect the plant to the grid,
Yes.
to give the electricity to the grid. See, for example, we are use our equipment for a few times. After this time, all is off. So we continue produce the electricity, we are continue produce. So the idea is to feed the electricity to the grid.
Okay.
Yes, where we are not using.
But now, for now, when you create the electricity, you create the energy, you use it.
Yes.
Okay.
It is used
So all the
inside.
power that is used here is from the waste.
From the waste.
Fantastic. Waste to energy,
Yes.
which is wealth. Okay. So you wanted to show me a process?
Yes.
Okay. Don't worry, I can jump, you know. So this is where you have the ratios.
Exactly.
The ratios of what you want.
Yes. After mixing, You see inside we have some stirrers
Ah,
to mix the material.
where are the stairs?
Yes, inside. This long one to mix inside.
How deep is this tank?
It is 4 meters.
You don't want to fall into this.
No, it is not.
Not advisable.
No.
4 meters.
Yes,
So what is the process? So it comes in here
it comes in here.
through where? Through here.
Yes, through here.
Okay.
So this is the sand. We take it off every Monday because the challenges is also we have even the cow dung are mixed with the sand.
So how do you take the sand out?
So the sand stay on the bottom of the,
Ah,
when we finish pumping, the sand stay on the bottom.
I see there's water. So
Yes.
you introduce water into the system?
Yes. We have 2 boreholes
Okay.
that is used here.
Okay.
We supply, this is our source of water.
Uh-huh.
We mix water plus cow dung plus organic.
Okay.
Yes.
And then what is the role of the water?
The role is water is the breakdown because in the biogas process, the first stage is hydrolysis.
Uh-huh.
Hydrolysis means to mix the material with water
Okay.
to break down the big molecule into the small one.
Okay. So this is cow dung plus organic waste.
This one is like sand.
Sand
Yes,
Okay,
coming from cow dung.
from cow dung.
After our process, this is our.
This is the sand from the cow dung.
From the cow
The
dung.
cow dung comes from there
Yes.
and goes in.
Yes, because the cow dung is also mixed with small
Ah,
sand.
okay. So how long does this process take inside this? What is this a tank? What do you
Yes,
call
this
this?
is the mixing tank.
Mixing tank. How long?
Pretreatment tank.
Okay.
That means when the material is inside, we are waiting for the material to be full in the tank.
Ah, it has to be full.
Yes. After we pump it from this, because we are seeing it is two tanks. One, the first one and the second one. So we send when the material is full. After mixing, we pump it. We transfer from this tank to
That
another
tank.
one.
Okay.
Yes, and from here we have some pump to feed the digester.
Okay. What is the digester is digesting what?
The digester is digesting all the organic.
Uh-huh.
Digester, that means they break down the organic material to produce the gas.
Okay.
And the gas is stored on the upper part of
In the dome?
in the dome, on the top of the digester.
Okay. Okay.
Yes.
What is the risk of explosion?
Oh, here we don't have any explosion risk
Uh-huh.
at this place.
Okay.
Any explosion risk, but it is
Inside there.
inside there on the top
Why?
because we can have some linkage of the
The gas.
gas.
Okay,
Yes,
okay.
the mixing of gas plus air. Yes,
And it
so-
causes a reaction.
Yes, this is explosive environment. So that means we cannot go in on the top without any recommendation.
Would you call this a reactor?
Yes, we can call it a reactor. The volume is 1,000 cubic meters.
1,000 cubic meters.
Yes, of the biogas.
Okay. And then it will produce how much of energy?
At this time, we don't have the device to monitor the daily production, but the storage is around 600
Okay.
cubic meters.
Let me ask a silly question. What does the gas look like?
The gas is, we cannot see, just sometimes smell.
You can smell it. What does it smell like?
It smells like some egg.
Okay,
Yes.
it's a bit rotten.
Yes.
Okay.
But when it smells like that, that means there is a lot of sulfury.
A lot of sulfur in it.
Yes.
Okay.
So
Okay.
H2S, we have to remove it.
Okay.
That is the way we are doing before using in the gas engine.
Okay.
So before going there, we have to analyze the gas.
Is it possible to see the analysis?
Yes, if you give us just some time to take the analysis from the lab
Okay.
and take it here.
And then you check it out. So exactly what's happening here? I see a briefcase.
Yes, this is the gas analysis.
Gas
Analyzer.
Okay.
We are going to analyze the gas before using in our generator.
So earlier you said you analyze the input. Now you are going to analyze the output. Is that correct?
Let us make the difference. The input is substrate, the
Yes.
material that is going in the digester
Exactly.
to break down, produce the gas.
Yes.
This is the input. The output is digested, the outside of the same material after production of the gas. So now we are going to analyze the gas
Okay.
to see what is the composition of the gas we have produced.
Awesome.
So, because before using the gas engine, we need some percentage of methane. The methane to be used as a fuel in our genset, we need to get methane more than 55%.
Okay. So the methane has to be more than 55%.
More than 55%.
And that's what you want to go and check here?
Yes.
Okay.
To check, is it possible to use the gas direct to our genset?
Okay.
Or we have other possibility of using of the gas,
Okay.
of the biogas.
What is Alan holding?
This is the gas analyzer.
Okay.
Yes, and we are follow the parameters like methane, CH4, the CO2,
Carbon
the
dioxide.
yes, the H2S, and
And
oxygen also.
Okay.
Yes, that is the main parameter we are going to follow.
To follow. Okay.
Yes.
All right. So I'm just curious how to go. So what will happen when the machine is ready? What will he do with this?
Yes, he put it inside. This is one analysis point.
Okay.
So we connect because this is the gas line. You see from the top.
There's gas in it.
Yes.
Okay.
All this line is full with gas.
Okay.
So this is the gas line. He open this valve and put the hose inside. The material, the machine has take the gas in and we have the composition of the gas on this machine.
So he will get the reading.
Yes.
Okay. Is it entering? Yeah, almost there. Okay. So the machine has to set before.
You set before.
Okay.
Yes.
All right. Okay. Interesting. I see him nodding.
Yes.
So now
he opened the valve. Yes. Here the gas is going through the analyzer, so we can get reading of the biogas quality.
Does it take a long time?
I'm thinking it's okay.
Okay. So please interpret the results for me. What do we have there?
So, as you are seeing, you have CO2. The value is 38.77%.
Okay.
You have the CH4. It's 61.95%. More as we are expected.
Okay. Is that the methane?
Yes, the methane.
CH4.
CH4.
Okay.
So that is the main value we are looking.
Okay.
This is H2H. It's not good for the gas engine.
Okay.
Yes, it can damage it.
Is that hydrogen sulfide?
Yeah, yes, hydrogen sulfide.
Okay.
Yes.
The one that makes the smell?
The smell, yes.
Okay, okay.
So we have a purification room that is specialized with the main purpose is to remove this H2S.
You need to be 0?
Yes, need to be 0.
Okay.
Or it can be no more than 5.
Okay.
It is not in percentage, it is ppm.
Okay. Parts per million?
Per million, yes,
okay.
Of course.
So the CH4 is the methane, 61.7. Is that good news for you?
Very good, very good. The way we are looking is no less than 55%.
Okay, so this is good quality gas?
Good quality gas.
Okay, awesome.
Very good quality gas.
Yeah, but you have good quality people doing the work, so
yes.
You get good quality gas. So now that he knows the gas is good quality, what happens?
Follow next step. We have to remove the small 2H2S we have seen.
Yes. Alan, thank you very much.
Oh, let us go on
around the other side.
Yes.
Okay, so the briefcase will go back.
Yes.
Thank you. Okay, so you have good gas.
Very good quality of gas. So
okay.
Just it is with 2 ppm of sulfur, hydrogen sulfate. It is okay.
Okay.
But it is better. The good situation is to have it 0.
To 0.
Yes.
Now, how many days does it take from waste to energy?
Oh, it is a continuous process.
Oh, it's continuous.
It is continuous process.
Okay.
When you are using a batch process, this can take you 30 days or 16 days sometimes. If you fill the tank and have to wait to produce all, yes, it can go to 2 months.
So this is continuous?
Yes. Now we are filling the digester every day.
Okay.
So as you see, you have some overflow. The overflow.
How do you know it's overflow?
Because when we are filling the digester, come and see, when the digester is full, by using gravity, the material get outside and came on this tank.
So it comes inside here?
Yes. This is the output.
Output?
Yes. That means the mix of organic plus cow dung we are putting here, analysis. This is the output of those materials.
Can we see what it looks like?
Yes.
Okay, I see it.
The smell is
gone. It's gone.
Not yes.
No
yes.
smell.
All the smell is going is stay inside the digester.
Ah,
Now this one is used as fertilizer.
I see.
Before use it as fertilizer, you make the separation. Here. This is the separator.
Okay.
Liquid, solid separator.
Separate.
So we take this one, we pump on this machine that separate the liquid part and the solid part. The liquid part is good fertilizer, good liquid fertilizer. We store it in one tank down there.
Okay.
We go there.
Liquid fertilizer.
Yeah, liquid fertilizer.
Okay.
And the solid fertilizer is taken to the compost,
Ah,
for the compost section.
I see. You know, there was one thing I was very surprised about, because considering you have a lot of waste here, I don't see many flies, even at the other side.
Yes.
I don't see flies around.
Yes, yes.
No insects flying around.
No. That is because when we receive the waste, we treat it direct.
Or you treat it.
Yes, we treat it direct.
Okay.
We don't keep it on site. No.
Okay, so you process it straight.
Yes.
Ah, okay.
And here, this is the purification room.
Okay.
Before use the gas to the engine, remember, we have 2 ppm of sulfuric hydrogen here when we analyze the gas. At this stage, we are going to purify the biogas.
It's coming from here.
No,
It's coming
gas
from the
line.
big tank.
Yes, the gas line is on the ground.
Uh-huh.
This is the solid part of the digester.
So the liquid part.
And the liquid part, all is there. Now it's the gas. I'm talking about the gas.
The gas now.
Yeah, the gas line is coming here. This is the purification room.
The gas coming from the top there.
From the top.
Okay.
From the top there and come here.
Okay. So the separations are there. Solid, liquid, and then the gas is at the top.
Yes, from the top.
Ah.
Come here.
And it comes here.
Yes. And here, before using in the generator, we have to remove the H2S.
Yes, the two that we saw.
The 2 we saw. So this is 2 tanks filled with activated carbon.
Activated
Carbon. Yes.
to take out
To take out
the hydrogen sulfide.
Yeah, yes, the hydrogen sulfide. So we can see, come. Don't worry, you can come. You can see here, the hydrogen sulfide go to 0.
Oh, 0.
Yes.
Nice.
That means the treatment process is working.
good.
Yes, working very well.
And the methane is 59.4,
59.4.
which is still good
Very good.
because you want minimum 55.
55%.
Awesome. Great stuff.
So after purification of the gas, we compress the gas. We compress the gas in this tank before get it inside the...
How do you, I know you can compress something which is solid. How do you compress a gas?
Yes, it is small compressor. We have a compressor. This is a compressor, gas compressor.
But we can't see gas. How do you compress gas?
Even the gas you are using at home, when you get it in the bottle, it's compressed gas.
What does it look like?
The gas is gas. Come and see. You can hear the noise.
It's compressed.
This is the gas, the compressor's one.
Okay.
So, this is also some
Okay.
checkpoint.
Checkpoint.
Yes, to analyze the quality of gas.
All right. Wow.
So
we're going here. Where is this here?
gas
Generator room. Electricity.
Electricity. This is the end of the process. From waste to energy. From waste to electricity. So it is working purely with gas, biogas. The biogas is filled inside and it's working.
So, how much electricity is being generated now? Can you tell from here?
Yes. Electricity.
$435 kilowatts hour.
Yes.
The energy that is running this plant, where is it coming from?
The energy
Running this one.
Yes, we are using it in the facility.
So the energy that so this goes to the facility.
Yes,
So when I turn the lights on in your office, it's from here.
yes. From here.
From waste.
Yes,
To
from
energy.
waste to energy. We have some internal use because inside the digester we have two stirrer, two mixer to mix the material together for optimization of the process. Yes, and also the pump and so on. That is the internal use, and also we have the energy as used in the other section.
Okay. So just to summarize what happened, the
Cow down
cow dung
and
and
organic.
the organic waste
Yes,
ends up in that,
yes.
and they separated
Inside the
digester.
break down and produce the gas.
Yes.
The gas is produced with by the bacteria.
Yes.
Yes. But after production of the gas is using after purification in the gas engine.
Okay.
And when the material already give all the gas inside, the output is used as fertilizer
Good. And you have liquid fertilizer
and solid
and solid fertilizer. And then the gas goes into the purification
Yes,
room.
yes.
And the idea is to take out the hydrogen sulfide.
Hydrogen sulfide, yes.
And we saw the evidence
Yes.
that it was zero.
Yes.
Okay. And then from there, the last level is the generator room,
Generator room.
where all the stuff that we took ended up to all the processes and
Here for the electricity production. In some case, we can get some challenges with maybe if we get some maintenance on the gas engine.
okay.
At the same time, the gas is continue. The process in the digester is continue. That means at some time we get some overproduction, over gas production. What are we doing with this gas?
What do you do with it?
So the way is we have two options. Burn the gas. This is a flare. Gas flare.
You flare it,
Yes.
so you can burn it.
We burn it
Okay.
to reduce the pressure over there because we have a limit of pressure.
Yes.
So, or we build this section. This is calling green hydrogen production section.
Green hydrogen.
Yes.
So the excess gas comes here?
Yes, we want to use the gas here to produce green hydrogen.
Okay. When you say green hydrogen, what does that mean?
It is the process reforming.
Okay.
Steam methane reforming process.
Okay.
This is the process here. Steam methane reforming process.
Have you started? Is there excess gas in it?
No. At this time, we are not yet. 95% is okay.
Okay.
So we are not yet commissioning the
So for now, when there's excess, you will flare it. You burn it.
the excess we burn it.
But a time will come when you will bring it here.
Yes, at time we bring it here.
And then what will you use this for, the excess one? You sell it?
This is at this time it is for research. We want to use it as fuel in the vehicle.
Okay.
Yes.
So it's a kind of a circular economy. You don't waste anything.
No, nothing.
Yeah. You also talked about solar power. Where is the solar power coming from?
We have the solar power. You see under the
On the roofs?
on the roof. Yes, rooftop.
Oh, okay.
This rooftop here
there.
it is compost section.
Okay.
So let us.
Yeah, let's go to the compost section.
Yes.
Wow. The compost section.
Yes.
So what are the components of this?
So this one is the component is organic material that coming from the municipal solid waste.
Okay.
The organic and also the solid part from the digester.
Uh-huh.
So the man in charge, the guy in charge of this section
Yes.
is also Mr. Alan.
Yes.
So he will explain you all the process, what is he doing here.
Okay. The last time we met, we were at the lab.
Yes.
Now, where are we?
Now we are at the compost section.
Okay.
Yes.
Describe what we see here.
Okay, so let's start right from here.
Mm-hmm.
So this is some dried corn husk.
Okay.
They serve as our carbon source in our composting process. Yes, now when we are composting, we want to ensure that there's a combination of nitrogen and carbon source. This is the mix that will make the compost. And here we employ the hot composting method. So what we do is that, like my boss has already mentioned, once we are done with the separation of the digestate into liquid and solid, the solid part is brought to this section, and then what comes in serves as our chief nitrogen source in our composting. Now what we do is that we mix the nitrogen source with the carbon source. This isn't the only carbon source we have. You know, here on our facility, we try to make good use of any recoverable from the waste that comes in. So we look for other sources of carbon like paper waste. So what we do is that we shred the paper waste, and then we mix with the dried corn husk.
Dried corn husk. Okay.
And then we have a particular C to N ratio we use in our processes.
What is
here
C
on
to
the-
N?
C to N is the carbon to nitrogen ratio.
Carbon to nitrogen. Okay.
Exactly.
All right.
So typically, if you are setting up the compost pile, what we do is that we want to base the floor with a carbon source. So we base with the carbon source. We have a particular height we want to go with the carbon source, and then we form another pile with the nitrogen source, another pile with the nitrogen. The carbon source comes again. So we get to the heights of compost.
It's like
that
a
we want.
massive
Yes.
hamburger.
Yes, it is.
Different layers.
Exactly.
Okay.
So we can see a lot of compost piles here.
Okay.
All of these piles are already in session. Currently, this is our active compost pile.
Active. When you say active, what do you mean?
By active, I mean the temperature profile is still rising.
Oh.
Yes. For the finished compost, you realize that the temperature has dropped.
Ah.
And like I mentioned earlier, we employ hot composting here.
So if I were to put my hand inside, I'll feel heat.
You would.
Okay.
So we can actually check with we can check the
You have a thermometer?
Yes.
Okay.
The current temperature reading. So with our hot composting, we target a maximum of 70 degrees Celsius.
It's now at 69.
69. So
Is that hot?
it is. It really is.
That can burn.
You can. I mean, if you put your bare
Oh,
hands
wow.
in there, you
69.9.
would feel the heat. Yes.
I thought it was Fahrenheit. This is centigrade.
Yeah, this is degrees Celsius. Yes. Yes.
Really hot.
Yeah.
And by the time it gets to the final stage, what is the temperature then?
So it drops to below 30.
Wow,
That's maybe an indication of completion, but then it's not conclusive. But just basing on the temperature to say your compost pile is done isn't enough.
Okay.
You will have to do nutrient analysis also to ensure that the compost is well formed.
Who uses this compost at the end?
So here on our facility, the compost actually serves two purposes.
Okay.
You know, the project also seeks to benefit the local community around. And then we are situated in a predominantly farming and environment. So the farmers directly benefit from the compost we produce.
Okay.
As a matter of fact, the first batch we produced was tested by local farmers around. And then we also have our maize.
Oh, some
farm
experimental
there.
farms here
Exactly.
to test your stuff.
Exactly.
So which of the heaps is ready for use?
Okay, so let's
Yes.
move down there.
I want to see what it looks like at the end.
Okay. All these are actually finished piles.
finished?
Yes, all these ones are
Okay.
finished. Yes, but then they all have varying nutrient
Okay.
levels and then pH.
Okay.
You know, sometimes when you are applying, you have to
Know the level, right?
exactly.
Yeah. Okay. So this can be used on the farms.
Yes, these can be. All these are finished compost, finished and sieved.
Wow.
Yes.
That looks great. Looks like ordinary soil, but it's more than that.
Yeah, exactly. It's really powerful. It's really powerful.
Good job.
So these ones have, gone through the process.
The process.
They've undergone curing
Okay.
and all that. What my guys are sieving there also is a powder that is recently done.
Okay.
So we are sieving and then we are going to take it to the curing process.
Awesome.
And then we do a final quality analysis and then we are done.
Thank you very much, Alan.
Thank you too.
I've learned a lot.
Right.
Okay, so behind us, describe what is behind us.
This is a solar panel.
You know, when I was coming, I thought it was just like
The,
normal roofing sheets. So it's an entire roof made of solar panels. Okay.
we have about 599 panels
Okay.
to produce a 200 kVA inverter to give us a 200 kVA power. And the purpose of the project is to initially is to use 100 kVA here in the facility and send 100 kVA for the community. Because the initial concept of the project is to supply power to the national grid. But initially, per the government restrictions, we have to produce about 1 megawatt before they can connect to the national grid. Because of that, we are just managing to use the power here. We are just still negotiating with the government to give us, because we are producing plenty power here. We have a power mix on the biogas, 100 kVA, pyrolysis this side. It's also going to give you 100 kVA, and the solar is 200 kVA. So we can't use all this power here.
No.
We have to give it to the national grid. If possible, the small factories around us can benefit, and also the community also can benefit. That's the main concept of the solar cell.
Yeah, this is a nice, brightly colored container, green,
Yes.
white, yellow. What's going on here?
Yes, this is the, I can say, technical room
Okay.
of the solar system. It's inside, we have the controller. We can go inside.
Yes, let's go in.
Yes.
Okay. So what do we see here?
Yes, here we are in the control room for the solar system.
Okay.
All the panel you have seen
Yes.
are connected here. This is the hybrid inverter.
Okay, what does it
Yes.
do?
Take the energy from sun, yes, from DC converter to charge the battery, and also from DC to AC to power the plant. We have, it is one of our energy sources. Yeah, it is in that place we manage it. Here we have a storage battery, but the capacity is very low. The aim is just to stabilize the solar production. So the autonomy is around 3 hours, just to stabilize. Because the idea is not to store the energy for a long time.
Okay.
So this is the process
Okay.
that is going.
Where does it start?
Yes.
From here?
Yes. At this time, the battery is full. The battery is full, though, so we are using the battery and solar. Yes, to power the load.
See.
Yes.
Very interesting.
Yes. So here, the capacity here is 100 kilowatts, but we can extend it to 200 kilowatts.
Okay.
Yes, that is the idea in
That's
the
the idea.
future. Okay. Because here, as we told in the introduction, is pilot plant, just to show that all those technology can be put together and produce something, some big thing and interesting.
Okay.
Yes, plants.
What is this machine?
Yes, to move from 100 to 200 kilowatt, this is an inverter.
Okay.
Inverter, yes. So we swap, change this. We plan to change this one and come to this. This is 100 kilowatt. This is 200 kilowatt.
I see. Good job. All right. Fantastic. Okay, Mr. Ashi,
Yes.
that was a really fantastic tour.
Thank you.
you very, very much. And now I can see clearly what the process is to take waste and then convert it to energy, different kinds of energy.
Yes.
What does the future hold for this particular waste to energy hybrid power plant?
Yes, in the future is to make the system in the other region across the Ghana and also the West African.
Okay.
In all the country where Wascal is represented. Because the project is under Wascal with the partner of Government of Ghana, University of Rostock. The Government of Ghana is representing the project by CSI and also KNSU University and so on. So in the future, the objective is to to represent, to reproduce the same project in the other country and in the other region across the Ghana.
I wish you nothing but the best. This has been a collaboration between the Ghana Broadcasting Corporation and the German Embassy in Ghana as part of the Climate Talks project. Hope you learned a lot, and God willing, we'll make this even bigger in the future. God bless. Waste to energy!